Good morning, everyone. Welcome to AP Stats. Today I'm going to review the homework problems, which were on page 129, 47 to 52, I think. Let's double check that. Yeah, 47 to 52. And then we'll talk about how to use a calculator to find z-scores more accurately and probably more efficiently as well. Let's see, 47. Bottom of 129, basically what it wanted you to do was use the table and figure out the area beneath or above or between z-scores. Also draw a quick sketch if you could. So 47, let's see, 47A, the answer would be 0.9978. B is 0.0022 because it is the complement of A. C was 0.9515, and D was 0.9493, similar to how we did them yesterday. 48A, 0.0069, B, 0.0069, C, 0.1798, and D, 0.1004. 49, A is 0.8587, B is 0.2718. And 50A, 0.7621, B is 0.241, 51A is a z-score of negative 1.28, and B, z-score 0.41. 52A, z-score 0.33, and B is a z-score of negative 0.67. So that's all it was. Using the table forwards and back to find z, and then using z to find area. And we move forward from there. So, as usual, guys, if you want to log in during the Google Meet today, during 8th period, feel free to do so, and we could talk about the answers to those questions, or if you have issues about what I'm about to say, again, that's the time to log in. All I really want to cover today is how we use our calculator. So, everyone take out your graphing calculator. Here's what I want you to do. All right, we're going to talk about how to shortcut, how to have an alternative to using the table. So, have your calculator on, and here's where we want to go. In order to find our shortcut for using the calculator, I want you to go to second, and then vars, stands for variables, and if you see the second choice down, it says Normalcdf. Let's pause here before we continue. What does Normalcdf mean? Well, normal obviously says we have a normal distribution, or an approximately normal distribution. That's the one with the peak in the center and it tapers off evenly to both sides. We've been using that for a little while now. If distributions are not normal, you can't use this. But we have adjustments in the future to allow for that anyway. CDF, it stands for Cumulative Density Function. It's important because there are distinctions between CDF and what we will use for some things in the future, which is a PDF, not the document, but a PDF stands for Point or Precise Density Function. We're not going to use it for the normal curve at all. So that first choice, it says normal PDF, pretend it's not there because you'll never use that one. Normal cumulative density function, that's what we're going to use. So go there, and it gives you this kind of screen, probably. It depends on your calculator. But it says lower upper mu equals 0, sigma equals 1, paste. Well, that means you're allowed to enter into the calculator a lower boundary or an upper boundary, as well as mu and sigma, 0 and 1. Let's stick to 0 and 1 for now, because that's a normal, standard normal curve, has a mean of 0 and standard deviation of 1. If you remember the answer from the previous homework assignment, the worksheet 2C asked you about the mean and deviation of a normalized distribution of Z. Okay, so here's what it means. Let's say the question is, let's say find the area under a z-score that's less than, let's just go with 1. First, let's use the table to see what the table would tell us. So, your handy, not so handy, table would tell us that under a z-score of positive 1, we would have an area of 0.8413. Well, here's what it's showing you. This is my curve. 0's in the middle. 1 is over here. So it's showing you that that area, which is certainly a lot of the curve, is 84.13% of the entire distribution. Let's see if we can get the calculator to give us a similar result. So, using the calculator, the first input we have to enter says lower. Now, mine automatically shows negative 1 E99. Maybe yours does too. Maybe if you have an older calculator, like an 83 or an older 84 that's not a plus or a silver, you don't even see this. Now, if you don't see this input guide, you have a different approach to what you're going to do. I guess I'll address that when we get to class today. But the lower boundary means that what's the lower z-score that bounds our shaded area? As you can see, I shaded down forever. Negative 1 E99 is negative infinity. Well, that's what you want, because the lower bound for the z-score, it just doesn't end. When it doesn't tell you negative 1 E99, maybe it's blank, maybe it's nothing, type in a very negative number, like negative 10,000. Usually we do use negative 10,000. That means it's 10,000 standard deviations below the mean. One would think that that will certainly take into account every possibility. Knowing that but beyond negative 3, it's only a little tiny amount of data. If you go to negative 10,000, it's ridiculously far out. So is negative 1 E99, obviously. So that's my lower bound. What's my upper bound? Well, it's where the shaded area stops, which is at 1. So enter 1. 0 and 1 are always the mean and standard deviation when you're working with z-scores. And we are working with z-scores. It says so right there. So paste and enter, and you get your answer, 0.8413447404. It doesn't end. The calculator is a more specific result. Now, granted, it was accurate to 4 decimals on the table, so it was fine. We do get confirmation here, okay? So, let's try another one with a different boundaries, okay? Let's say it's, what's the area under a z-score above 2? Unlike the table, your calculator can handle this without worrying about the complement rule, without worrying about subtracting from 1. Because what it's really saying here is, here's my curve, here's where z is 2, I want this upper area. Now again, on the table, you would have had to find the area under 2 and subtract from 1. But we don't have to do that now. All we have to do is go back to Normalcdf, so second vars 2. My lower boundary is no longer a negative infinite bound, it's the number 2. My upper boundary is a positive infinite bound, so what number am I going to type in there? Positive 10,000. If you want to type in 1 E99, feel free, but 10,000 is a good estimate for the essentially boundless right side of this curve. 0 and 1 are still our mean and deviation. Paste, enter, we get 0.02275, but we got to go to only 4 decimals, so 0.0228. 2.28% of my data is contained above a z-score of 2. Okay, what if I want to find the area between negative 1 and positive 0.7. Well, now I have two boundaries. I have a lower and an upper boundary. So there's no boundlessness here. Again, second vars 2. The lower bound is -1. The upper bound is 0.7. So we got it all. Enter, go. I got 0.59938, so 0.5994. 59.94% of the distribution under a standard normal curve will lie between z-scores of -1 and positive 0.7. It's so much easier than the table. Plus, it's more useful. And there's no benefit to using the table. We just have to know how to use the table for if that is a question on the AP exam. It would not be on the open-ended portion. It might be a multiple choice question. They might give you an excerpt of the table and ask you something. It's certainly possible to be on the test. Okay, so that's how we're going to use the calculator for finding the area under a curve using a normal distribution. Okay, so far so good, not too hard. The other thing I want you to know for today is that because we can only use this function for normalized curves, we have to make sure that our data is normal sometimes. So here's what I want to show you. I'm going to give you a data set, and we're going to do what's called a normal probability plot on the calculator again. So here's my first data set. Ready? We'll just keep it easy. 1, 2, 2, 3, 3, 3, 4, 4, 5. Maybe you can see that it's going to be a normal distribution. It starts low, doubles here, triples there. It's going to be certainly symmetric. Here's how we're going to use that. Go to Stat and edit the first. Clear out whatever you've got in list 1 by hitting clear and then enter. And then type in the data. So 1, 2, 2, 3, 3, 3, 4, 4, 5. Okay. Now, in order to see if our data is normal, we're going to use what's called the normal probability plot. So I want you to go to your stat plots. That's second y equals. I lied to you. Don't go to your stat plot. Just go to, I'm sorry, I didn't lie. I just didn't finish what I wanted to say. There you go. You see how all of mine say off? You want one of them to be on. So I'm going to select the first one, and I'm going to make sure it's now on. Under the type, you got all these options. Now, each one is a different graph. So the first one is a scatter plot. The second one is a line graph. Then there's a histogram. Then there's a modified box plot. Then there's a regular box plot. Finally, the last one, that is your normal probability plot. Now, hit enter on that so that it selects the normal probability plot. It says data list L2. Actually, my data is in L1. So I got to fix that. Second one, and now it's going to look at the correct list of data. Data axis X, the mark doesn't really matter. The color, of course, doesn't matter either. I'm going to hit graph, and I have to be very careful after I hit graph because that's a weird looking picture. Whenever you do a stat plot, you're going to want to zoom 9. See the 9? It's for stat. Say 9 is zoom stat. So hit 9, and then magically it gives you the best possible window for the picture. I want you to look at this and tell me if you see something important. It looks fairly linear, doesn't it? A normal probability plot tells you the probability of your data being normal. And it tells you by showing you a linear pattern. If the data looks to be linear, that means the data is approximately normal. The less linear the graph looks, the less normal it's likely to be. So, to demonstrate that, I'm just going to change my list from what it was to, let's say, 1, 2, 2. I'm only going to have 1, 3, 1, 4, and I'm going to add a couple more 5s at the end. So here's what it looks like now. And we're going to see how normal that data looks on a normal probability plot. The good news is I've already selected the graph I want. So all I have to do is hit graph, because the last thing I graphed was the normal probability plot. Now I'm going to zoom 9 again, just to make sure that it's the best possible window. And doesn't that look terrible? Look how bad, look at the far right. It's vertical, it's terrible. Is this showing you a likely normal distribution? No, it is not. So that's all the normal probability plot shows you. It shows you how normal your data is likely to be. And you can also determine if there's significant skew, if it looks like it's got a long right tail, long left tail, whatever it is. Okay? Sometimes you have to run the normal probability plot to make sure that your data is normally distributed, because if it's not, you really can't use normal distribution rules. Okay. Now, the homework for today is on page 132 and 133, but 132 is really just the instructions. It's on the very bottom right corner of 132. It tells you what to do for the problems that continue on 133. I want you to do numbers 70 through 74. That's it. 70 through 74. Of course, since today is Friday, it's not due till Monday. But if you want any help or any advice, log into today's Google Meet for 8th period, and I will absolutely offer you that help or advice. Other than that, have a great day, have a great weekend, and I will see you guys on Monday.